Welcome back to our MCP training series, Session 1, Core Concepts and Architecture. In this session, we're getting into the core of Model Context Protocol, and if you've ever wondered how AI tools talk to external APIs or databases, then you're in the right place. MCP is what makes that possible and powerful. MCP stands for Model Context Protocol and is a standardized way for language models to interact with tools, data sources, and external applications. Think of it like a translator between your AI model and the rest of your digital ecosystem. What makes MCP so special is its architecture. It's modular, flexible, and designed for work with any programming language, be it Python, Java, JavaScript, .NET, you name it. Here's how it works. MCP uses a client-server architecture with three main roles. The host, like VS Code or Claude Desktop, is where the user interacts. The client lives inside the host and talks to the server. The server provides tools, data, or prompts that the model can use. If you've ever used an AI agent that could look up a document, call a weather API, or generate code templates, it probably used something like MCP under the hood. Let's break it down further. Hosts are where user prompts originate. They manage the UI, permissions, and connect to servers. Clients handle the back and forth, sending prompts to servers and returning model responses. Servers expose resources, tools, and prompts. They're the workhorses doing the actual lifting. Servers can provide three kinds of features: resources, like local files, database entries, or external APIs; prompts, templates that guide AI behavior; and tools, executable functions that the model can call, like git commands or weather fetching. This is where MCP really shines. Tools are like plugins for your AI. You can define them, control their access, and use them to make your agent both smarter and more helpful. Here's how all of these parts communicate. When a user makes a request, the host initiates the connection. The client and server negotiate capabilities, what tools or data are available. The model might request a tool or a resource. The server executes it and sends back the result. Finally, the client integrates everything into the model's response, and the user sees the result. All of this happens using a structured message format called JSON RPC. It ensures clear, predictable communication between components, whether you're using WebSockets, standard input-output, or server-sent events. MCP builds on JSON RPC with added features like capability negotiation, tool invocation and result handling, request cancellation and progress tracking, authentication and rate limiting, and most importantly, user consent and control. Security is baked in. Every tool call, every data access has to be approved. That means users stay in control of what's shared, what's executed, and what gets exposed to the model. MCP is your bridge between AI and the rest of your digital world. It's modular, secure, and built for real-world integration. Whether you're debugging in your IDE or building custom agents, MCP helps your models act on the world, not just talk about it.
That is for this session. In our next session, we're discussing one of the most important topics in AI development: security. If you're building with MCP, it's not just about making things smart, it's about making them safe. See you in the next session.